Okay, so what I want to do today is I would like to add some asteroids to our asteroid game, which I'm going to call meteors. The Google Classroom, where I included the pictures, which I got from Kenny's Assets, or you can make your own. And what I'll be using is two different size asteroids. We're going to start with the first ones, and then we'll add some smaller ones. Well, I'm not going to call them asteroids. I'm going to call them meteors because that's what the name of my pictures are. So I'm going to make a list to handle those as well. This project is all about getting better at lists. If you can understand lists and loops, you can program pretty much anything in the world, I think. Very powerful. Meteors. Meteors. There we go. And so we now need to create some meteors. Now we could create them right here in this line of code, or we could write a function that creates the meteors. I think I'm going to write a function that creates the meteors. So I'll say def make meteors. And this will be nice as well because then we could use it for like different levels or something. And because we're going to need this is a setup method. I'm going to call this method before I run pgz run because pgz run needs to be called only after you've done all your setups. So the way that we're going to do this is we're going to make some meteors and then add them. This is going to feel very similar to making walls in our maze game. All right. So the first thing I'm going to do is I'm going to say rand x. Oh, have we imported random yet? Oh, we need that. We're going to import another one. We're going to say from random import randint. So I'll be using the randint function from the random module. I could say just import random, but then I'll have to say random.randint every time. Now I'll be able to say just randint. If you prefer random.randint, you can do that as well. It doesn't matter. All right. Now that I've done that, I can actually do this. So rand x. I'm going to say that is going to be equal to randint, 0 to width. That will be a random integer. Remember, integer means whole number, starting at 0 all the way up to and including the width of the window. Rand y. Okay. And then I'm going to say rand angle equals randint 0 to 360. So we're going to have a random x, a random y, and a random angle. There is one problem here. We don't want this to be able to be in our... We don't want it colliding with our rocket. So that could be a problem we'll have to address by moving it and preventing it from being in certain places. But we'll deal with that later. All right. Now that I've got that, I'm going to make a meteor. The meteor is an actor. And in order to do this, you will need to have in your Rocket Defend folder, you're going to need to have the meteor. I have a meteor small. We'll make those later. But for now, you need to have a meteor image. So mine is going to be meteor.png. And it's going to go to randx, and these have to be in parentheses because they're an xy coordinate. Randx, randy. And then meteor dot angle will get my rand angle. All right. And then we're going to put it on our list. So I make a meteor at a random x, a random y with a random angle, and I add it to my list. I would like to do that 4 times. So I'm going to put all of this code in a for I in range for loop. Highlight everything and hit the tab key and it'll move over perfectly. So that's kind of how I design my code. I say, well, let me think, how would I want to make one of them? And I concentrate on making one. I wanted to make one meteor and add it to my meteors list. And then I think, okay, how many times do I want to do that? And I put it in a loop for I in range, how many times I want to do that. And now it's done. But I need to be able to draw them on my board. Nothing will be drawn in this game unless we draw it. So we'll have to go back to our draw function, and we'll have to iterate through this list and call the draw method on each meteor. So let's do that. So I choose K because I already used I. I don't want to use I again. Meteors, bracket K, dot draw. So K will be 0, 1, 2, 3, or however many meteors are made. And so I'll draw the meteor in the list at index 0, 1, 2, 3, each one at a time. Now that I'm drawing to the board, and this might be a good chance for us to check our code to make sure everything's where it's supposed to be. And I'll be darned, you look at that, right off the bat, I have an error. Check early, check often, my friends. All right. Okay, I have a pile of meteors. And they are not moving around the screen at all. But, at least I got fun flying around them. Oops. I don't know, it's oddly satisfying. I'm picturing a top-down racing game that might be fun with this, Anyway. So that's super and all. Let's make a move. So our update function, remember the procedure is between every frame, if you click the button or press down a button, it will run the function on key down or on key up. But barring that, Python will call update and then it will call draw. So we're going to update the rocket, we're going to update the missiles, we're going to update the meteors. So let's do that. This is a fun function to do. First of all, let's make a meteor speed. I'm going to start with a pretty slow speed of 2. And I'm going to do for I in range len meteors. I am not actually removing a meteor right now. So I can use a for I in range loop. If I decide that I want to remove meteors later, I'll need to change this to a while loop. Okay? But I think I would do that in a separate function anyway. So I can go ahead and iterate with the regular for loop. Remember, this loop is fine as long as you are not removing from the list. That's when that causes problems. All right, if I can find it in my notes here. I know I have it somewhere. Ah, there it is. So I'm going to go ahead and just get a meteor. So I don't want to type meteors bracket I every time I want to do something. Because you're going to see we're going to have about 10 lines of code here, and that's a lot of typing. So all this does is assign the letter M temporarily the meteor in ith position. So if I have 4 different meteors, it'll be the first, the second, the third, the fourth. And that allows me to just say M dot to do my code. Okay? First of all, let's get a vector. So we talked about the vector class that we downloaded the other day. The vector class constructor is what we're calling right now. It takes an angle and a speed, and it creates a change in x and a change in y. So I'll do m.x plus equals vect.getDx m.y plus equals vect.getDy. So if you recall from yesterday, a vector is a set of instructions that describes how to get from point A to point B, given the angle to get there and the speed you want to go. So it tells me how much to change my x and how much to change my y by. So first I create the vector, and the vector has 2 methods that I can call getDx and getDy. D means changing. So I'm increasing x by what the vector says to change by, changing y by what the vector says. Pretty simple stuff, but important. All right, now what we're going to do is our meteor, if it goes off the top of the screen, it's going to appear again at the bottom of the screen. So if the meteor's bottom, which is the bottom y coordinate of the actor, is less than 0. Remember, 0 is the top of your screen because it's not like algebra class. 0 is the top y value, and then the height is actually the bottom. The y's count up going down. So this is saying off top of screen. All right? Well, then we're going to move the top. We're going to move the image so that the top is at the height of the screen. So I'll add another comment. Move to bottom. So I check if the very bottom of my meteor is off the screen. If it is, that means the entire meteor is off the screen. Right? If just the top were off the top of the screen, it still have part of a meteor on it. But then I move the very top of that meteor all the way down to height, so it'll appear to come up on the screen. Okay? Next, if my meteor's right-hand side is less than 0, so that means the far right side of my meteor is off the far left of the screen. In that case, I'm going to move it to where the left-hand side is at the width. If the meteor's top is greater than the height. Now, really important here, don't put this. That would be bad. Because at this moment here, we just moved it there. Do you remember? It has to be strictly greater. If that happens, we're going to move its bottom to 0. And remember, we checked earlier if bottom was less than 0. So it's okay. Last one. If the bottom of it is less than 0. Wait, I already did that one. Oh, you know what I'm missing? I'm missing the if left is greater than width. That's the one I'm missing. That's the one. I need 2 heights and 2 widths. M not right will equal 0. Okay, cool. Okay, if we run this, we should have some very happy little meteors running around the screen. And when they go off one side, they should appear magically on the other. I am thrilled by this. Huzzah. All right. Okay, hopefully you're having a super fun time flying around your meteors. But currently, our meteors cannot be destroyed. Fortunately, they also cannot destroy us. We'll handle destroying us last because we're going to have to make a few little adjustments to the placing of the meteors when we do that, and I don't want to handle that right now. So we are going to we're going to check for collisions. Check for missile collision. So I'm going to check to see if my missiles have collided with my meteors. That's a pretty long name for a function, I know, but I like to have my code be readable. Okay, so we're going to do this in 2 iterations. First iteration, when we shoot a missile and we hit a meteor, the meteor will go away. In the second iteration, what we're going to do is if the meteor is a big meteor, instead of going away, it will go away and be replaced by 2 smaller meteors going in opposite directions. And thereby better replicating the original, wonderful game. Let's do the first iteration here. Now, because we're removing from a list, we should not use the for loop. For loop and removing from list, very, very bad. So what we're going to do is do a while loop. Oh, to do a while loop, first I need to make an index. I'll just start with I equals 0. While I is less than the length of the list of meteors. Okay? Now, what I need to do is I need to loop through the entire missiles. I need to check every missile to see if it's been hit by this meteor. So I'm going to say M equals meteors, bracket I. So M is a meteor. And I need to check it with all of my different missiles. So I'm going to say, I don't like that because I'm using a lot of letters. Let's just call that meteor. So we're getting a single meteor is equal to meteors bracket I. So that'd be better because this is going to get kind of confusing otherwise. Okay, K will be my index for my missiles. And I'll say, while K is less than the length of my missiles. So we're looping through all of the missiles now. So I have meteor, that is the ith meteor, missile, which is the kth missile. If meteor dot collide rect if meteor dot collide rect with missiles bracket K, missile, then we're going to pop meteors dot pop I missiles dot pop K. So we go through every meteor one at a time, and we ask, are you being hit by the first missile, the second missile, the third missile, etc.? As soon as we find a missile that is intersecting with that meteor, that's the collide rect, means one object's over another, we actually remove both. If you would like to not remove the missile, that'd be okay too, but then you'd be able to carve through the meteor and get the meteor behind it, which is up to you as a programmer. But I went ahead and popped both the index of the meteor and the index of the missile. Perhaps it would be better if I labeled these as what they are, but I'll just use a comment. Index of meteor, and this is the index of missiles. So we have to loop through every meteor, but for each meteor, that's why it's indented, right? Each meteor, we have to loop through every missile. That's me getting the kth missile, checking if it collides with it, and there we go. That is how this is actually a pretty common thing for collision detection between lots of intersecting objects. So if you run this code, you should be able to... well, I say that, but now I run mine and it's getting mad at me. I'm not really sure why. Not responding. Okay, I am so sorry, but I failed to up my K and my I. So I need to do an else on each one of these. Else K plus equals 1. And I plus equals 1. Yeah, no, it wouldn't need to be indented, but let me think about that for a second. Okay, massive apologies for how complicated this is going to be, but we're going to make a value called hit, and we're going to say it's false. Okay? If the meteor gets hit, I don't want to remove the meteor here, and I also don't want to keep looping through. So I'm going to stop the loop when the meteor is hit. So I'm going to say, while K is less than the length of the missiles and not hit, then instead of popping the missile there, I'm going to say hit equals true. Then here at the bottom, I'm going to say if not hit, I plus equals 1. So this is a pretty complicated algorithm. I'm going to do my best to explain it, but, it builds character, so let's go for it. All right, so I need to keep track of a lot of different things here. Let me pull up Paint here so I can I like to draw, while I'm doing this. So 1,000 pardons, but we need while K is less than missiles and not hit. I just said not hit. I need an and right there on line 32. All right, so now we have if not hit, we increase the I by 1. We need to say else. We're gonna do meteor dot pop I. All right, so I'm just making one small. I made a couple of small changes to this just to make it, I think, easier to explain. But I changed the order. I said if hit, meteors pop, else I plus 1. And now what I'm going to do is I'm going to try my best to explain this. All right, so we're going to try our best to go through this method one at a time so we can understand lists a little bit better. So what I like to imagine is that these little stacks of boxes are actually a list. This is my list of meteors, and this is my list of missiles. Okay? So we're dealing with pretty much the ultimate in complexity here. Two lists interacting with each other. I'm going to I'm going to call this, M1, M2, M3. Well, actually, that's confusing because the other one's A. But I'll call it A for asteroid, okay? A1, A2, A3, and A4. And over here, I'll say, that's what I'll put M1, M2, M3, M4. Actually, forget that. We'll start it at 0. M0, M1, M2, M3, M4. And we'll start these at 0 too. So that's better named. Computer science namey, right? All right, so this will be asteroid 0, asteroid 1, asteroid 2, asteroid 3, and asteroid 4. All right, so we're going to start with our missiles, with our meteor index at I. So at the start of the function, we start with I equaling 0, which means that I is literally referencing or pointing to this index here. And we're going to, what we do is we're going to get that meteor and call it meteor, okay? So wherever you see meteor, meteor in the code from now on in this function, meteor is talking about the meteor that I is pointing to, okay? K is going to be referencing a missile. So we're going to start at K of 0. And then you'll notice that I say missile equals missiles K. So where every time you see the word missile, it's referring to the missile that K is pointing to. We're going to create a variable called hit, which is currently false. So hit is currently false, saying this meteor has not been hit. All right. So when we start with this outer loop here, the while loop on the outside. So this loop is going to loop through all of the meteors. This loop here is going to loop through all of the missiles, okay? So we're going to start at this moment right here with missiles equal missile K. So this is missile, that's meteor. We're going to ask the question. We're going to say, is this missile hitting this meteor? And let's pretend that the only collision we have is this missile is hitting this meteor, okay? So the answer here would be no. It is not. Because it's no, we do not change hit to true, we do not pop that missile, and we move K plus 1. We go here. Is this missile hitting that meteor? No. Is this one? No. Is this one? No. Is this one? No. All right, at this point, K moves to beyond the length of the missiles. And so because of that, this loop is now done, and now we pick up in the black outer loop right here at if hit. We never changed hit to true because we never got hit. So we're not going to pop that meteor, and instead we're going to advance I. I will advance to here now. So you see we're having to keep track of two different pointers in these lists. Now I moves to there, and we go back to the top, okay? I is less than the length of meteors. Meteor is now this meteor. K goes back to 0. See how I send K back to 0? While K is less than the length of missiles and not hit. We just set missiles to hit the false, so it's not hit. Is this meteor hitting this? Is this missile hitting that meteor? No. So we move K plus 1. Is that hitting it? No. Is that hitting it? Yes. We have found a missile that is hitting a meteor. So what do? I change hit to true. So hit is now a true statement because we have hit something. And I pop K. So popping the kth index of missile, this missile is gone. All of these move forward. I come back up to the top of this while loop, and K is still less than the length of the missiles, but now not hit is no longer true. This is not a true statement anymore, okay? Because hit is true, so not true is false. So we exit this loop and then come down to here. It says if hit, we were hit. Hit is true. If true, you could also say if hit equals true if you really wanted to. Meteors pop I. So that means this meteor is gone and all these other meteors, I need to set my secondary color back to... All right, this meteor is gone, causing all these other meteors to slide forward in the list. Okay? And we don't advance I, so now we'll go through that whole procedure again, starting K back at 0, and we'll go through and we'll check each one of these for this new asteroid, and then I will move down again. We'll start K here, and remember, only that one missile is touching. We'll go through, then we'll move it to here, and then we'll go through, and they don't hit either, and then we'll finally be done. So hopefully that made a little bit of sense to you. That's a little bit more complex method than you would expect in a Computer Science 1 class, but hey, we can conquer it, right? Once you've done that, you should be able to destroy missiles. So, yeah, they can get pretty complicated when you're dealing with list of things with list of things. When you're dealing with just one thing that you can remove or get rid of, it's a lot easier.